Hello, my dear JEE warriors and lions. Welcome to yet another amazing and exciting session of all the JEE 2024 PYQs, unit-wise, which we are covering up in this particular series. And today we are going to discuss all the PYQs from Electrostatics and Gauss's Law, a very important and very, high weightage chapter. Also involves a lot of other concepts like vectors, free body diagrams, maybe sometimes even Newton's laws here and there. So we'll discuss all these concepts with these particular questions, right? So get ready for the session, and before we start the session, you need to give your fees, you need to give your Guru Dakshina by smashing that like button. And if you don't want to miss any other classes, you need to be subscribed on this particular Vedantu JEE English channel. Okay, so do that. Thank you so much. Yes, your Captain Shreyas is here, and let's start with the questions one by one. If you find that any question you need to again watch the solution, you can rewind it at any given point of time, right? So let's begin, and here comes the first question. We are starting off with MCQs, then we'll go to numeric type. This question says there are 5 charges situated as shown in the figure. The electric flux due to this configuration through the surface. Remember, the flux through any closed surface depends only on the charges inside, and that is basically your Gauss's law. So the total flux is the total enclosed charge divided by epsilon naught. Now what exactly is this inside charge? 5 plus 1 and minus 2. So that is plus 5, then plus 1, and then there is minus 2 over here, which is nothing but 6 minus 2, which is nothing but 4 times of Q. So 4 times of Q is there in the numerator, and in the denominator you will have epsilon naught. Hence option D should be the correct answer. Direct application of your Gauss's law. Minus 4Q will be producing electric field, but it will not affect the net flux over this entire closed surface because it is outside. Even this plus 3Q is not going to affect because it is outside our closed surface. Here comes the next question. There are 2 charge conducting spheres having radius A and B. They are connected to each other by a wire. What is the ratio of the charges on both the spheres? Now, when you have 2 conducting spheres connected by a wire, what happens is the potential of this sphere will exactly be equal to the potential of this particular sphere. The potentials become equal because the wire equalizes the potentials of any conductors being connected across them. This has some radius, this has some another radius, A and B. So what is the voltage of any sphere which is conducting? It is Coulomb's constant into the charge on that particular sphere upon the radius of that sphere, which in this case is A. Same way, K, charge on that particular sphere upon the radius, which is basically B. K gets cancelled. QB can be shifted below QA, can be shifted below QA, and I can shift this number A on the top in the numerator. B remains over there as it is. So the ratio of the charges is the ratio of the radius itself. So it is option C. So many students might make a small silly mistake and mark it as B by A if you write the ratio in a reverse manner. So the answer is option C, by equating the potentials. Very straightforward. Okay. So these are the kind of questions which are asked, guys. But you will see towards the end, the questions become more difficult. There are complex questions as well. Okay. But it also tells me that, okay, this chapter is huge. There are many concepts involved. In spite of it, I can score marks in at least few questions. So that's why don't neglect this chapter. If you're thinking even remotely, remove that thought away. Okay. You can definitely score marks. Some complex questions, how to solve them, we'll see that as well. Now there are 2 identical conducting spheres, charge Q on each, repel each other with some force. A third uncharged sphere is brought in contact with these 2 spheres. What is the new force between P and S? Very interesting question. So imagine 2 identical spheres, P and S. So this is P and this is S, having charge Q each. This is having Q, this is also having Q. They are repelling each other with some force of how much? 16 Newton. So 16 Newton is the force, and by Coulomb's law, 16 Newton will be K into Q divided by the distance between them. Let's say it is R, so R square. Now just imagine you bring a third ion charged identical sphere R. What will happen because of that? See, first time when you touch P with that uncharged sphere R, what will happen? That charge which was there on P, which was Q, will get distributed equally. So this will become Q by 2. This will also become Q by 2. So that Q by 2 is distributed from that sphere P equally in both the spheres. Now you take that sphere R and now you are making it touch with the other sphere S, making it touch with the other sphere S. Okay, now what will happen? The total charge of this particular system, the total charge of this particular system is not Q, because S already had Q charge on it. S already had the charge Q on it, plus R also had a charge which is Q by 2 on it. Remember, in the previous scenario, the total charge was Q and it remained Q till the end. Here, the total charge is actually 3Q by 2. That means half of 3Q by 2 will be distributed equally. So this particular sphere will have 3Q by 4, and this one over here will have 3Q by 4. If you add both of them, you will get 3Q by 2. So that is the new charge distribution. Now let's come back. What is the new force between P and S? P has now, in the new scenario, P has how much charge? It has Q by 2 charge. And the sphere S has how much charge? It has 3Q by 4 charge. The separation between them is smaller. So the new force between them will be given as follows: K into this charge, which is Q by 2 into 3Q by 4, the whole thing divided by R square. So you can see you have KQQ divided by R square over here, multiplied by 3 divided by 2 fours are basically 8. Now what is KQQ by R square? As per this equation, it is basically 16. As per this particular equation, it is nothing but 16. So might as well replace this particular part by 16. The remaining part stays there as it is. 16 goes with 8 2 times. So 2 multiplied by 3 is nothing but 6 Newton. So 6 Newton should be the answer, which is B for IIT Bombay. If you loved the way this question was framed and solved, make sure you're smashing the like button, because your encouragement, your motivation, and your Guru Dakshina is needed for more of these sessions. Okay? So do not forget to like, and if you have not yet subscribed, do that right away, right now. Alright, let's move ahead to the next question on your screen. Sigma is the surface charge density of a shell of radius r. The electric field at any point on the surface of the shell. Whenever you take the shell, okay, if this is your surface of the shell or any conductor for that matter, remember electric field is perpendicular and it is present outside. Inside the shell, electric field will be 0, and anywhere on the surface of a conductor, the electric field formula is sigma by epsilon naught. When you take a sheet, the field goes both ways, then it is sigma by 2 epsilon. When it's a conductor, the field goes on one side, so there is no 2 in that expression. So it is just sigma by epsilon naught, which is there as option number B for IIT Bombay. Isn't it amazing? Let's move to the next question, guys, coming up on your screen. Okay, get ready for it. In a hydrogen-like system, the ratio of the Coulomb force and the gravitational force between an electron and a proton is of which order? Simple calculative question, but let's do it. Question is Coulomb force upon gravitational force. Force of Coulomb upon force of gravity. Coulomb force is given by K, Q1, Q2 divided by R square. Gravitational force is given by G, M1, M2 divided by R square. R square goes. So K, Q1, Q2 divided by G, M1, M2. Now, K value is 9 into 10 to the power 9. Charge of electron and proton is the same, 1.6 magnitude wise, 10 to the power minus 19, and again 1.6 into 10 to the power minus 19. Then you have the gravitational constant, which is 6.67 into 10 to the power minus 11, and the masses of electron and proton are roughly of the order of 10 to the power minus 31 and 10 to the power minus 27. Solve this, you will get the answer. Obviously, the Coulomb force will dominate as compared to the gravitational force, because we know at a short distance in a hydrogen-like atom, the Coulomb force will be much, much larger than the gravitational force. So it will be a very huge number, comes out to be 10 to the power 39. Imagine the number of zeros in 10 to the power 39. So it is 10 to the power 39 times stronger than the gravitational force. That is why when we draw an electron moving around in an atom, we never show the gravitational force, because that is so negligible as compared to the electric force. Electric force are strong and dominating at short distances. For very large distances like Earth and the Moon, the gravitational force dominates between celestial objects as compared to the electrical force. That's how it is. That's why gravitation is considered long range. Electric force is considered to be a short range force. A charge cube is placed at the center of one of the surface of the cube. What is the flux associated with the cube? Whenever you get such kind of a question, obviously start off by drawing the diagram. Without that, you cannot proceed. So just imagine a cube like so. And it is said that there is a charge on the center of one of the surface, not at the center of the cube. There's a difference on the center of the surface. So what will happen? The electric field lines will go like this. Another field line will probably go like this. Another field line will probably go like this. Another field line will go like this. Right? You can visualize so many such electric field lines going in different directions. Right? Can you see half of the field lines are going this side? The remaining half are going in an imaginary cube. You can think of an imaginary cube right over here, guys. You can think of an imaginary cube right over here, something like this. If you draw that imaginary cube, I know it is not existence, that's why it is called imaginary. Then these two cubes together become a new closed surface, and the total flux through this entire closed surface will be Q by epsilon naught. But half of the flux is going through this cube, half of the flux is going through the other cube. Hence, I would say through this imaginary cube, the flux going is Q by 2 epsilon naught, and through our real cube, the flux going is again Q by 2 epsilon naught. If you look at it sideways, it is clearly seen. Your charge is over here. The electric field lines are probably something like this, and our actual cube is somewhere here, and our imaginary cube is exactly over here. Together, it's a completely closed surface. Total flux would have been Q by epsilon naught. Half the flux is going here, half the flux is going through the other cube. So a lot of people by heart certain things and they say, sir, it is Q by 6 epsilon or Q by 24 epsilon. Guys, it depends on where the charge is placed. If you place it at the vertex, then it is different. If you place it at some other point, it will be different. So it depends from question to question. Hence, the answer for this should be Q by 2 epsilon naught. Brilliant framing of the question. Again, we have a new type of question. An infinitely long wire, thread like, has some density, and there is a charged particle going around it with the wire as the axis in a circular path. The graph that represents the kinetic energy as a function of the radius of the circular path. This question has been repeated in different ways in different years also, let me tell you. See, let's understand what is exactly happening over here. If you take a long wire having some linear charge density like this, and if you go somewhere, let's say at this particular point at a distance of r, then if you place some charge over here, it will go in a circular orbit. It will go in a circular orbit like this, provided there is some kind of a centripetal force being provided by something, and that can only happen because of the electric field applying a force on this charge. So this force provides the necessary centripetal acceleration, this force being electric in nature, between the wire and this charge, which is the field produced which is nothing but the field which is produced by the wire multiplied by the charge itself. What is the field produced by the wire? What is the field produced by a infinitely long wire? Well, it is 1 by 2 pi epsilon naught lambda divided by the distance. In this case, the distance is r. The q value comes over here as it is equal to mass. Mass of that charge is m. Centripetal acceleration is velocity square divided by r. The best part is the value of r only gets cancelled. You can see we got mv square. So how about multiplying it by half? So half mv square is the kinetic energy, right? Half mv square happens to be the kinetic energy, and on the left hand side what do I get is lambda by divided by 2. So 2 into 2 is 4 pi epsilon naught, and q is there on the top. So the kinetic energy is independent of r, so it is constant. Hence this should be the graph. Hence, this should be the graph. Graph 1 it is increasing, graph 3 it is decreasing, graph 4 it is linearly increasing, graph 4 it is independent. It is the same for all the distances. The reason for that is because the R value just got cancelled out. What a brilliant question. It was just pure coincidence. And like you can see, a very similar question was asked in 2024 again. But this time, instead of the graph of kinetic energy, they have asked the time period will be how much. So use the same formula which you have got it till here. So from the previous question, so from the previous question, what do we get? We get this following thing: lambda q by 2 pi epsilon naught, lambda q by 2 pi epsilon naught is mv square, is nothing but mv square. From this you will get velocity as root of lambda q by 2 pi epsilon naught m. Once I get velocity, I can find the time period. Time period is nothing but circumference by speed. Circumference, distance by speed. So it will be 2 pi r divided by the speed, which is over here, but it is reciprocal. So whatever is there below will go on the top. So 2 pi epsilon m will go on the top, and lambda q will be there below. So that's it. That is the answer. So 2 pi r on the top and everything else as it is over here. Now here, remember I have put 2 pi epsilon naught, which I can convert it into Coulomb's constant also. There is nothing wrong in it. So I can write 2 pi r, and instead of 2 pi epsilon, I can write it 4 pi epsilon naught. But the moment I write it 4 pi epsilon naught, I have to also preserve the equality by dividing by 2. Lambda q will be as it is, and you will have m. 1 by 4 pi epsilon is k. So 4 pi epsilon will be 1 by k. So hence you will get 2 pi r, and here you will have m, 2 lambda q, and k will be there below, which is exactly option number D. Is that right? Understood? So this was a very, very important concept because it has been repeated twice in the same year. Even if you check older papers of 23 and before, you will find the same concept being asked in different papers. Okay, so that means it is a important model of question. So this model is important. What about this question? There are two hollow concentric cubes enclosing 2q, 3q, the ratio of the flux. So always questions on Gauss law are very, very popular, yeah, with NTA. So 2q is there inside the smaller cube, 3q is there between these two. So what will be the ratio of the flux passing through cube 1 upon cube number 2? So total charge in cube number 1 upon the total charge in cube number 2. Total charge in cube number 1 is basically 2q. Total charge in cube number 2 is 3q plus 2q. Is 3q plus 2q. So hence it is 2q divided by 5q, which means it should be 2 divided by 5. How did we get this? Because we know flux is nothing but q inside divided by epsilon naught. That was the logic behind this. So hence 2 by 5 is the correct answer. Very straightforward. Within 20 seconds or 30 seconds in the examination hall, you will be able to crack it. Okay, it doesn't take much time. Perfect. Let's move on to the next question coming up on your screen. What does it say? It says that there are two charges In vacuum, force is F. You change the medium, change the distance, what is the new thing? If you know, this model is also very popular. You touch the spheres, what is the new force? You immerse the sphere, what is the new force? You change the distance, how many times does the force change? Common model of questions. So let's do this. So initially, when the distance was r, the force is F. So by Coulomb's law, it will be K Q1 Q2 divided by r. Next time what happens? The new force, I will call it F prime, will be the Coulomb's constant divided by dielectric constant is 5. So it will reduce 5 times. The charges are the same. The distances r by 5. So r by 5 whole square. So here also square was needed. Yeah, perfect. Now what I can do is K Q1 Q2 by r. Just look at this. Out of all these variables, K Q1 Q2 by r with the square, I can separate it out. And the remaining things I will just write it down. This number, sorry, this particular number 5 was there as it is. This was 1 by 5 whole square. So 5 square goes on the top. 5 square by 5 is just 5. Okay. And what is this? KQ1 Q2 by R square. KQ1 Q2 by R square was our original force. So it has become 5 times of that. So 5 times of that, which means A is the correct answer. A is the correct answer. Cool. So like I said, these kind of questions, again, very, very common. Moving on to the next one. There are two charges, Q and 3Q, separated by some distance. Which distance from charge Q, the resultant field is going to be 0. Resultant field. Let's draw it, obviously. So imagine there is Q over here and R distance. Let's say there is 3Q over here. At which distance from charge Q, the resultant field is 0. So let's assume that distance from that charge Q is basically x, which we need to find out. So from 3Q, it will be obviously r minus x. Due to Q, the field will be here. Due to 3Q, the electric field will be here. If I call this as field 1 and this as field 2, they should be equal. Reason, because net is 0. Net is 0. So to cancel it out, we need it. The resultant field, electric field is 0, clearly mentioned. What is electric field at this point due to this charge? It is K Q by x square. At this point, due to this charge, will be K into 3Q divided by R minus x whole square. K, Q cancels. So 3 divided by R minus x whole square will be 1 by x square. Take root on both sides. So root 3 divided by r minus x is 1 by x. Cross multiply. So root 3 times of x is r minus x. Take x on the other side. So x into root 3 plus 1 is r. Take root 3 plus 1 below. So r by 1 plus root 3. So r by 1 plus root 3, which is option number C for your Captain Shreyas. That is the correct answer. So sometimes they might ask you what is the net potential at this point. Sometimes one of the charges could be negative. All these are common model of questions where there are 2 or more charges and they will ask you where the field is 0, where is the potential 0, what is the potential where the field is 0, what is the field where the potential is 0. All these are common type of questions, guys. Okay, so just showed you how to solve it. The electric potential due to electric dipole at a distance r varies as, I mean, if you are in this shift and you got this question, probably you are the luckiest fellow out there. Why? Because this is directly formula based. Potential, lot of people feel, sir, the formula is KQ by R. Lot of people think it is inversely proportional to R. They mark B for IIT Bombay, but that is not correct. Remember, when it is a dipole, the formula is slightly different. The P value has the dimension of length. So it is something like this, Kp by R square cos theta. So it is actually inversely proportional to R square, which means it is D for IIT Delhi. Okay, so be really careful. In a hurry, in haste, you might tend to mark it as 1 by R. These are common silly mistakes. So for simple problems, you need to be extra careful because there is a reason why they would have put such a simple question. Okay, moving on, next one coming up on your screen. Electric field is given. The flux through a surface lying in the YZ plane is how much? Flux is electric field dot area vector. Electric field is 6I plus 5J plus 3k. Area vector is in the YZ plane. That means the vector will be pointing in the X direction. So it will be 30 I cap. Okay. I cap will only multiply with I cap. J and K, it can't multiply. It will end up being 0. So 6 I cap into 30 I cap is what is going to be left over. Rest all terms of J and K will be 0. So I into I is 1. 6 into 30, guys. That's going to be 180. 180, C for Captain Shreyas. That is the correct answer. What a brilliant or simple, I would say, question. Right? Perfecto. Perfecto. Let's move on. I hope you're enjoying the session and solving it with me. And wherever you feel like, no, sir, I want to take some time and solve it by myself and then look at the solution, feel free to pause. Because obviously it's a recording. You can pause it any number of times, try it on your own. Maybe just watch a line of the solution, get some idea, and then try to solve it. Still you don't get it, maybe then you watch the entire solution. That would be fun, trust me. There are two charges, two different points, the flux through a sphere of radius 4a. Okay, let's draw it first. So we have x and y axis. There are charges 5q. Where is 5q? 5q is at 3a, 0. This is basically 5q. This is at a distance of 3a, 0. 3a, 0. Where is minus 2q? It is at minus 5a. This is minus 2q. This is at minus 5a, 0. Through a sphere of radius 4a, center at the origin. Radius is 4a. See, if you draw a sphere of radius 4a, it will not pass, here. This point will be inside of it. So if you draw a sphere, 100%, this point will be a part of it. Inside the sphere, this won't be. So this will be outside, whereas this would be inside. So the flux, electric flux, is always the inside charge by epsilon. The inside charge is 5q and epsilon is epsilon. So 5q by epsilon, which is D for IT Delhi. Yes, that is the correct answer. So, the question looked so probably intimidating, meaning scary, that, oh my God, sir, something coordinate geometry might be involved, some equation of lines might be needed, something else is there, it had to visualize in 2D or 3D. No, nothing. Very straightforward. Whether it is inside or outside, decided whether flux has to be calculated or not. Moving on to the next one. The electric charge is placed at the origin. The points P and Q are situated as shown. Potential difference between these 2 points. So, okay, again we have to draw y-axis and x-axis. Our charge is placed at the origin. How much is it? 10 to the power minus 6 micro Coulomb. There are 2 points. Point P is at root 3, root 3. So this is point P. Point Q is at root 6. Okay. So what is the formula for potential in general? It is K into Q divided by the distance. So what is the distance of this point from this point? The charge to this point, what is the distance? Well, use the distance formula. It will be root 3 square plus root 3 square, whole thing under the root. Root 3 square is 3 plus 3, which is basically root 6. So root 6 is the distance of that point P from the charge. What is this distance? Well, it is already on the x-axis having a coordinate of root 6. So RQ is root 6. Interesting thing, the distances are same, charge is the same, K is a constant. So if RP is equal to RQ, obviously potential at point P will be potential at point Q. The question is, what is the potential difference between points P and Q, which is Vp minus Vq, both being the same? The answer should be a big fat 0, which is C for Captain Shreyas. So these questions, which look scary, you might think that there might be some crazy 3D geometry or some conic sections or I don't know, straight lines involved, actually ends up being a very simple problem. The answer was a big fat 0 because both of them were at the same distance from that particular charge. So they did not have only any potential difference at all. Okay, moving on. Assertion reason. Wow. The 2 statements are given. Assertion reason, which of them is correct or wrong, or explanation is correct or wrong. Work done by electric field on moving a charge, positive one, on an equipotential surface is 0. Yes, equipotential surface, whether you take positive or negative doesn't matter. If you move it on that equipotential surface, the work done is always 0. So assertion is 100% correct. Reason: electric lines are always perpendicular to the equipotential surface. Yes, if this is the equipotential surface, electric field line, they are always perpendicular, and electric field only creates that force. So if there is no force along the line of that displacement, there will be no work done. So yes, is it explaining it? Yes, definitely. So I think it should be both are correct, and reason is the correct explanation. Yeah, because if electric field is perpendicular, the force is also perpendicular, so work done will be 0 when you move it along the equipotential line. Correct. Wow, we have come on to the numerical part now. I hope you are ready for it. Now the questions will become slightly maybe lengthy or tricky, or involve some multiple concepts. Okay, so we have come to that section number 2, yeah, where you have numeric type of questions. I hope you have smashed the like button. Just a quick reminder, in case you haven't, do that right away, right now. Okay, here we come with the first question on your screen. The electric field exists in space. A cube of 2 meters is placed as shown. What is the flux through the entire cube? If you notice the electric field carefully, you will realize the electric field is only going in the x direction. There is no y or z. That means the sides which do not experience flux are this, this, and even this, and even the one which is behind. I hope you are able to visualize it. Basically, the flux through the top, the flux through the bottom, the flux through the front face, the flux through the face which is behind, all these faces the flux is 0. The only place where the fluxes are there is on the left face and on the right face. If you look at the left face, here is the catch. At this point, the electric field is probably like this. I'm just showing small teeny mini vectors over here. And what's the magnitude of this vector? Well, it depends on the x coordinate. Well, the x coordinate on this particular plane, remember, x coordinate will be 2. X coordinate will be 2. So substituting 2 into 2 is 4. So it will become basically 4 I cap. But if you go on this surface, I think the x coordinate itself will be different. The x coordinate will be 2 plus this 2, which is 4. So the electric field vectors will be little bit longer. Deliberately I'm showing it so that you get a feel of it. So 4 into 2 is basically 8. So 8 I cap is the electric field over here. Right? Now if you notice the surfaces that we are talking about, okay, let me make it slightly big, is this one surface over here and this one surface over here. If you measure the electric flux at this particular point, the flux it's going out, the flux which is going out will always be positive, and it will be the area of the cube face. Side length is 2. Side length is 2. So what is the area? The area will be 2 into 2, which is basically 4 meters square. So hence it will be field multiplied by area, which is basically 32. Whereas over here, the flux is coming in, hence it will be negative, and area is still 4. Field is 4. So 4 into 4, so that's minus 16. Therefore, the net flux, will be 32 is going out and 16 is coming back. Hence, the remainder is 16. Answer is 16. Perfect. We got it. It's a brilliant question. A lot of people end up adding 32 and 16. You forget the sign convention. Remember, flux going out is always because of positive. Flux is going out is positive, and flux which is coming in will be because of a negative charge present inside. So that's why it is negative. You have to take into account signs. Remember, just because flux is scalar, do not discount that it can't have signs. No, just because something is a scalar quantity does not mean it can't have signs. It can have. Charges have sign, they are scalars, correct? Even current can have sign. Even electric potential being a scalar can have sign. Forget all that. Even work, which is a scalar quantity, has positive and negative sign. Even power can be negative and positive. So do not forget, flux also has signs, and especially for a closed surface, outward is positive, inward is negative. Keep that in mind. Moving on to the next question on your screen. At the center of a half ring of radius r, the linear charge density is this much, the potential is how much? Okay, so half ring, that means I will show half of the ring. This has some charge over here, linear charge. What is the potential at the center? You take any charge on the ring, it is at the same distance r. So the potential at the center is the sum of the potentials due to all the small charges on the ring, all the small charges on the ring. And the potential due to any point charge on the ring will be k into some delta q upon the radius of the ring. K is a constant, R is also a constant. So I can just bring it outside. So it will just become K divided by R sigma small delta Q charges I can take here. Delta Q charges I can take here. So if I add all the charges, I will basically get the total charge on the ring. I will basically get the total charge on that ring. Now what is the total charge on the ring? Well, it is nothing but how much charge you have per unit length multiplied by the length of the wire. Multiplied by the length of the wire. Remember, lambda was Q divided by L. So Q will be lambda multiplied by L. So length of the wire will be pi r. That's the semicircle's circumference. So instead of Q, you just replace it with lambda pi r, and you will get K, and then divided by R over here, R cancels. So lambda K pi, lambda K pi. Lambda is given, how much is it? 4 nano coulomb per meter, and this is 10 centimeters. So it will be some 4 in the answer will be there. So some 4 will be there, and you have to also substitute 9 into 10 to the power 9 because K value is 9 into 10 to the power 9 over here. So substitute that. So 9 into 4, and that is 36. So 36 pi is the answer for this particular question. Okay, very straightforward. But this derivation was very interesting. So in spite of this being a semicircular arc, all the charges were equidistant no matter where you go. All the charges were basically equidistant. So when you added the total potential, you saw that the distance term came outside. It was just the net charge which came into the picture. Everything else just vanished because it was constant. It just came outside. Correct? Let's go to the next question, guys, coming up on your screen. Okay, what do we have? The net electric field at a point P along the y-axis is 0 and the ratio of the charges is how much? Interesting question. Maybe I might need more slides. Let me just create a duplicate of this just for the space sake. Okay, let's see. The net field at this point along y-axis is 0. See, this charge Q2 will give an outward, radially outward electric field. So when you reach this point, the field will be in this particular direction. Now, this is the electric field due to the charge number 2. Obviously, it will have two components, one component here and another small component over here. Same way, this particular charge, negative Q3, will have a radially inwards field because it is negative charge along this line only, right? So along this line only. So I will show it like this. It will also have two components, one here and maybe one over here. So this is basically electric field due to charge number 3. Okay. Now, because net field along y-axis is 0, this guy's y component and this guy's y component should cancel out each other. So what is the electric field y component here and what is the electric field's y component over here? For finding that, I think I also need these distances. This is 2, this is 4. So what is this distance, this dotted line from charge Q2 to that point P? Use Pythagoras, of course. So it will be nothing but root of 2 square plus 4 square. 16 plus 4 is root of 20, which is this particular distance. And this particular distance, this is 3, this is 4. So root of 3 square plus 4 square, which is 9 plus 16, which is 25. So root will be 5. So this is 5 centimeters or whatever, 5 units. 5 centimeters. Perfect. Now, once I have got that, I think I can write what E2 and E3 will be respectively. E2 will be K into the charge, which is Q2, divided by the distance square, which is root 20 square, of course. And what about E3? E3 will be K Q3 magnitude wise divided by distance, which is 5, so 5 square. But we have to take the components of it. So E3 is some cos, maybe I call it theta, and maybe over here I will call it phi or something. Okay, so we have to take the cos component so that we can cancel it out. Oh, but wait a minute, I don't even know what is cos theta here, unless, oh yeah, cos theta is adjacent by hypotenuse. Cos phi, this phi will be same as this angle over here, so this is phi. So when I find cos of phi, it will be adjacent by our hypotenuse, which is root 20. Keep that in mind. Okay, let's start. So E2y will be numerically equal to E3y. So what is E2y? It will be E2. E2 is basically K Q2 divided by root 20 square, which is 20, into cos phi, which will be numerically equal to K Q3 divided by phi square, which is 25, and you will have cos theta. What is cos theta? Cos theta is adjacent by hypotenuse, so it will be 4 divided by 5. Same way over here, what will be cos of phi? Cos phi will be adjacent by hypotenuse, which is 4 divided by root 20. Interesting thing to note is that a lot of things get cancelled, like this k and this k will get cancelled, and you will probably see even this 4 and this 4 will get cancelled. Solving this, obviously you are going to end up with the ratio. You're going to end up with the ratio. What is it? Q2 by Q3 magnitude ratio will be solving this, and it comes out to be as 5 units. Okay, it comes out to be as whatever 8 by 5 root something, so it just probably comes out around this number. Yeah, 8 by 5 root something. So that root x is what is given over here, and you have to find that x, and that x comes out to be 5. So basically the root value is as follows. So it comes out as 8 by 5 root 5. That should be the answer. So what you have to find is x, which is 5. Okay, cool. Very, very interesting question. Resolution of vectors is involved. If you miss any angle, you make a mistake in the resolution, you will definitely get a completely different answer. Okay, cool. Let's move on to the next one coming up on your screen. Electric field is given, passes through a surface and having some unit vector. The electric flux. My God, this is again a repetitive pattern type of question. This was asked again before in some different way. Flux is electric field dot area. Electric field is this whole thing, 2I plus 6J plus 8K. The whole thing divided by root of 6. Area vector is not given, but magnitude is given. Magnitude into the unit vector is the vector itself. So it is basically 4 multiplied by this whole thing. So I can just put the number 4, then I can put 2I cap plus j cap plus k cap, the whole thing divided by root 6. Remember, any vector is the magnitude times that unit vector. That is how it can be represented. Root 6 into root 6 is basically 6, and you multiply the rest. Root 6 into root 6 is basically 6. 2I cap into 2I cap is 4. 6j cap into j cap is just 6. 8k cap into k cap is just 8. And this whole thing gets multiplied by 4 as well. Correct? And you can now divide this with 2. Divide this with 2, it will be 3. 4 plus 6 is 10. 10 plus 8 is 18. So 18 by 3, and you have 2 over here. 3 goes with 18 6 times. So the answer will be 12 units, which is the correct answer. Okay, straightforward, guys. This logic was involved over here. The vector is the magnitude times the unit vector. That's it. That is the concept which was needed in between. Otherwise, it was very simple, right? Okay, moving on to the next question. Okay, three long sheets are placed as shown in the figure. The magnitude of the electric field at this particular point. See, this minus sigma will create an electric field here. This minus 2 sigma will create an electric field here. This plus sigma will push it, so it will create a field here. All the fields are in the same direction, so they will all add. How much is each field's magnitude? By the way, remember, due to any large sheet, the field is independent of the distance. It's basically uniform. The lines, field lines are parallel, so distance does not matter. So don't worry about these distances. It is chumma given to just play with your head. That's all, nothing else. So due to minus sigma, it is sigma by 2 epsilon. Due to minus 2 sigma, it is again 2 sigma by 2 epsilon. And due to this sigma, it is sigma by 2 epsilon naught. Wow, a lot of sigmas over here. So add them up. So the net field will be sigma plus 2 sigma plus sigma divided by 2 epsilon naught. So this will be 4 sigma by 2 epsilon naught. And what is there? X sigma. Okay, so this is 2 sigma by epsilon. So 2 is our answer, I believe. Yes, the answer is 2. The answer is 2, like you can see over here. Perfect. Okay, X sigma by epsilon naught was asked to us. Let's move on to the next question on your screen. Electric field at this point, it's on the axis of a dipole, okay, is E. What's the field at a point R on the equator? Okay, not that difficult actually. Electric field on the axis, basically at point P, is given by the formula 2K P divided by the distance square. Here distance is basically R. Sorry, distance cube. So distance is basically R. Okay. Now, if you go at this point, electric field at equator at that particular point R will be, there is no 2 in that. Dipole moment is same, divided by the distance. Distance is now 2R. So 2R whole cube. Okay. So it will become Kp, 2 cube is 8. So 8R cube. Now if you notice over here, Kp divided by R cube, take that number 2 below, is E divided by 2. Kp by R cube is E divided by 2. So Kp by R cube, you just put it as E divided by 2. This number 8 is as it is. So it will just become E divided by 16. So E divided by 16, that means answer for the unknown X is the number 16. Yes, that's the correct answer. So you should know the difference in the formulas on the axis is 2 versus on the equator there is only the number 1. On the axis the field is twice as strong as compared to that on the equator. Also the field varies inversely proportional to the cube of the distance from the dipole, assuming the dipole is short. Okay, not square, the cube of the distance. Yes, correcto. Let's move to the next question on your screen. Like you are able to see, all these numerical questions are either on large sheets, long wires, right? And some coordinate axes where you have to visualize it. So this was a common trend which we found in JEE 2024. It also means that in JEE 2025, you can expect that if there is a particular model of question which is asked in any one of the shifts, most likely that model or that some changes are expected in that, and similar questions you can expect in other shifts as well. Okay, so there is a long sheet, charge having uniform surface charge density placed on the xy plane, another long line charge having uniform line charge density, z is equal to 4 parallel to y-axis. Numerical value is this. The ratio of the magnitude of the field at due to the sheet to that of the line charge is this much. What is the value of n? Okay, so let's start by drawing. Without drawing, we cannot proceed. So here we go. This is our x-axis. This is our y-axis, and this is our z-axis. Okay, something like this. The sheet is placed on the xy plane. Okay, so our sheet is basically the xy plane. Our sheet is basically the XY plane. Keep that in mind. Okay. Sheet is XY plane. Okay. And another long wire is placed at Z is equal to 4. Z is this axis. Z is equal to 4 will be somewhere here, parallel to the Y axis. Okay. So our another wire which is there is like this, maybe somewhere over here. So this is that wire. So again, imagine now there is a long wire in front of a large sheet. Are you able to visualize that in 3 dimension? This is our large wire having charge density lambda. This is having charge density sigma. Now see what happens. Because of the sheet, if you are at which point 0, 0, 2, xy coordinates are 0, z coordinate is 2. So that means at this particular point, which is 0, 0, 2, only on the z axis you are lying. Due to the large sheet, the electric field will be in this direction. Due to this long wire, the electric field will be in this direction. I hope you are able to visualize it. Okay. And both are positive. That means it will be away. The ratio of the magnitudes of the fields is asked. All right, let's do that. How much will be the electric field due to the sheet? How much will be the electric field due to the sheet? Simply put, it is sigma by 2 epsilon naught. Distance does not matter. Keep that in mind. The electric field due to the long wire, infinitely long wire, okay, that formula is given by 1 by 2 pi epsilon naught lambda divided by the distance. This is z is equal to 4, this is z is equal to 2. So the distance from here to here, how much is that? How much is this distance going to be? It is going to be 2 meters. So it is just going to be the number 2 over here. That is what it is. Now you just need to divide both of them. So E will come below. So you will have lambda over here and then 2 pi epsilon naught multiplied by 2 on the top. Similarly, ES due to the sheet is here. So sigma will be on the top, 2 epsilon will be here. You can see few of the things are definitely getting cancelled out, like our epsilon and epsilon. Okay, pi is probably remaining, no issues. All right, and then you can see that sigma is twice of lambda. Sigma is given, this is clearly mentioned to be, it's given to be twice of lambda as per this expression over here. So again, we have few things cancelling out, like this lambda over here and this lambda over here. This number 2 will cancel out with this number 2. So what I am effectively left out with, is, check this out, this 2 is there, this pi is there, this 2 is there. That's all. So basically only 4 pi is there. Only basically 4 pi is there. Now the ratio is given to be 4 pi is to 1. No issues. Can I write it in terms of root? I can write it like this, pi root 16 divided by 1. So the number that I'm expecting is the number 16. Hence the answer is 16. Yes, 4 is the root of 16. What a simple calculation, but visualization was very important. If you don't visualize it properly, you will just get confused. You might just get lost in the formulas. Interesting thing is, due to a large sheet, the distance does not matter where you calculate the field. Uniform field, everywhere it is the same. For long wire, it is inversely proportional to the distance. That distance was given to be 2 meters as per the diagram. Okay, moving on to the next question, guys. Get ready for it. All amazing questions in the numeric type. Here it comes. A uniformly charged wall produces some field. A charged particle is being suspended through a thread and remains at some distance. What is the charge on that particle? Okay, let's imagine that wall first of all. Let's imagine that wall. Imagine this wall is somewhere over here, something like this. Maybe show it this. This is your large wall, and then there is a thread which is attached to the charge and connected to the wall. Okay, so there will be different kinds of forces. One will be, of course, the tension in the string. Then there will be gravity of that mass which is experienced. The wall itself is producing field. So this charge will experience an electric field given by the charge multiplied by the field. Of course, I can now draw a vertical line and I can say this is theta, and then I can split the tension and equate the forces for equilibrium. So it is clearly mentioned it is in equilibrium. Okay. So what happens is the net force must be 0. So if you go in the horizontal direction, the tension's sine theta component will cancel QE, will be balancing who? Q into E. Similarly, the tension's cos theta will be balanced by mg. I can see what should be our next step. You just divide these two expressions. So dividing both, I will get sine theta by cos theta. Tension cancels, is nothing but QE divided by mg. So sine theta by cos theta is nothing but tan theta. So tan of theta is nothing but QE divided by mg. So therefore, Q will be mg times of theta divided by the electric field. The mass is given, I believe, somewhere 2 grams. So 2 into 10 to the power minus 3. G is basically 10. We'll come to tan theta in a bit. Electric field is 2 into 10 to the power 4. As per the given information, the charge is at some distance. How much distance? 10 centimeters. This is 10 centimeters. And the thread length is 20 centimeters. If this is theta, obviously even this is theta. If this is theta, even this is theta. So what would be tan of theta? Well, tan theta will be opposite by adjacent, but adjacent I do not know again. So to find this height, use Pythagoras. So it will be 20 square minus 10 square, correct? 20 square, guys, 400, 400 minus 100, 400 minus 100, basically 300. So it will be 10 root 3. So this height is basically 10 root 3. So tan of theta opposite by adjacent. So 10 root 3. 10 cancels. So 1 by root 3 remains here. Okay. So 1 of the 10 also goes here. Perfect. So 2 also cancels. So I'm just left with 10 to the power minus 6. The whole thing divided by root 3. So it also means it is 1 micro coulomb divided by root 3. 10 to the power minus 6 is micro. So hence the value of x must be 3. Yes, that is the correct answer. You can see that. Okay. Simple question. That's why I said Newton's laws sometimes could be involved. Vectors concept will be involved. So whenever you are doing electrostatics and Gauss law chapter, make sure your Newton's laws, vector resolution, motion in 2D, these chapters should be pakka. These chapters should be clear in your head. Moving on to the next one. The distance between the charges Q and minus Q is 2L. Between 2Q and minus 2Q is 4L. The electric potential at a point P is how much? Okay. Now, if you just consider this dipole, that is from here to here, due to this dipole, which is having a dipole moment of Q, and the distance is 2L. So Q into 2L is the dipole moment. The electric potential at this point, using the formula K P cos theta, okay, cos of 60, whole thing divided by R square, divided by R square. That is what it is. P is basically 2QL. So K into 2QL cos 60 is basically half, and over here you have R square, that is potential due to this set of dipoles. Now you go to the another set of dipoles. You can see that dipole which is having a little bit larger length, this one, that is your P2, which is having dipole moment of charge which is 2q into the distance. Distance is how much? 4L. So 4L, that means it is 8QL, which is the dipole moment. And that point P with respect to this dipole moment is making an angle of 120 degrees. So the dipole moment will produce a potential of K P2 cos 120, whole thing divided by R square. So K is K, P2 is 8QL, cos 120 is negative half, and then you have R square. But what do we want? We want the total potential. Total potential is potential 1 plus potential 2. Few of the terms are obviously common, like K is common, Q is common, L is also common, Q is common, L is common, R is also common. What is left is from here, I have the number 2 by 2, 2 by 2, and from there I have the number minus 1 by 2 multiplied by 8. Perfect. This is what is being left over. So what do we have then? K, Q, L divided by R square. 2 by 2 is 1, 8 by 2, that's 4. So that's minus 4. 1 minus 4 is minus 3. So we get the number 3 with a negative sign. So you can see over there, exactly similar answer is expected. Alpha, I believe, will be, we have to substitute the value of K also. K will be 9 into 10 to the power 9. So 9 will be there and 3 is there. 9 3s are 27. So answer should be 27. Perfect. That is the answer. Remember that. K value is 9 into 10 to the power 9. You will also have Q. You will also have L. You will also have R. And you have 3. 9 3s are 27. Rest of the things are, just taken outside the brackets common. Alpha is asked. The value of alpha will be 3 into the number 9, which is 27. Perfect. What a brilliant question, guys. These kind of questions, again, very, very interesting, opening up your minds. Hopefully, you are enjoying the session, right? Shall we go ahead to the next question? Okay, this question on density and dielectric has been repeated in the previous years. Same concept is repeated again here. There are two strings equal lengths that are suspended from a same point, make some angle. When suspended in some liquid, the angle remains the same and density of the liquid is given. The dielectric constant is how much? Okay. Originally, these two would look like this, making certain angle. Let's say theta and theta. If these two charges are separated by some distance, what you will see, the forces acting are the repulsion forces. Then you will also have tension and you will also have mg, and this would be obviously theta. So repulsion force will be kqq, which is q square, divided by the distance, which is r square. So the tensions sine theta, which is horizontal, will be balanced by kq square by r square, and the tensions cos theta will be balanced by mg. You divide both of them, what you will get is tan theta is basically kq square by mg r square. That is what you will get. In the next step, what happens? The only difference is these two wires are still there. These two wires are still there. Apart from your regular tension, mg, and electric force, you additionally get the buoyant force. That's the only difference. Distances, etc., everything is the same. So additionally, you are just going to add one extra buoyant force, and that buoyant force is V rho g, volume of that charge, volume, because density is mass by volume, so volume will be mass by density. So it will be nothing but mass by density, but I think mass is not given, so let me keep it as it is. Rather, I would suggest to convert this mass into the volume part, because the density of the sphere is given. Mass is density into volume, so density of the sphere into the volume into g. That is what I would recommend. That means over here as well, because mass was not given, so here also we'll put it as sigma v g. So here also sigma v and g. So that's the only difference, guys, in the second part of the problem. So again, what will you get? Tan theta as, think about it, you will get tan theta as, instead of t cos theta being sigma vg, you will get it sigma vg minus rho vg. That's the only difference, minus rho vg. So what you get over here will be k q square, divided by sigma Vg minus rho Vg, and then you will have r square over here. There's one more small thing. The electric force will no longer be kq by r square. It will be reduced dielectric constant number of times. Now, usually the symbol of dielectric constant is K, and the Coulomb's constant is also K. Can be confusing. So maybe I use some different symbol to just put it over here. This C happens to be the dielectric constant. This C happens to be our dielectric constant. Okay. So don't get confused. So what will happen when I divide these two expressions? I will get C in the denominator. I'll basically get C in the denominator. So I get, for the second case, tan theta is this. For the first case, without this and this, I will get this as the expression. Because tan theta is the same, I can equate these two. These two tan thetas are exactly the same. We can equate them. So on the left hand side, we'll have kq square divided by sigma VGR square is being equated with this whole thing, which is kq square divided by sigma Vg minus rho Vg, and then you have r square also and constant also. Many things will get cancelled, like this kq square, even this volume, even this r square and this r square, even this g here and this g here. So lot of things just get cancelled, my dear warriors, and what you are just simply left with is 1 by sigma minus rho into this particular constant, into this particular dielectric constant. Flip it upside. So sigma will be sigma minus rho, whole thing into C. So C will be sigma by sigma minus rho. That's all. So you know all the values of the density, which is basically 1.4, and here 1.4. Density of the liquid is basically 0.7. So 1.4 divided by, this is again 0.7 only. This will go 2 times. So the dielectric constant must be 2. Yes, that is the correct answer. Perfect. So I did not use any of these values till the end because that is a better approach for many questions with a lot of values. You keep it in variable form because you don't know what might get cancelled, what is not used, right? So we saw that most of this data, like 37 degrees was not needed, mass was not needed, right? Gravity value was not needed. It just got cancelled and it becomes simple. So just to give you a quick recap, first we did the problem, check the dark blue part with only gravity, tension and electric force. Second time what we have added is the buoyant force, and this electric force will also change. It will become 1 by k times the dielectric constant times in the second case. So that is why I have put that C below. That's the only change. Again, if you divide it, you will get tan theta. But the theta value was same as per the given question. It was given. The angle remained the same. Cool. Right. Here comes the next question where we have a sheet of some density, an electron some distance away, having some velocity, finding the value of sigma so that it strikes that sheet within 1 second. What's that value of alpha? Okay, let's visualize this. Let's draw that sheet first. Imagine this is the sheet. So it will create an electric field both sides. Once here, obviously here too. The value of the electric field, of course, will be sigma by 2 epsilon naught. Now just imagine an electron over here having a velocity of 1 meter per second, having a charge negative E and mass m. Okay, right over here. So now this electron will experience a force because of the field. Because it's a negative charge, field is that side, so the force will be on this side, and even the acceleration will be this side. And eventually what happens is that electron goes and probably hits this particular surface. At 1 second, it will strike it. Okay, so let's start by finding the acceleration. But before that, the force. Force is the charge multiplied by the field. The field is sigma by 2 epsilon. Acceleration is force by mass. So acceleration will be this entire thing, which is sigma E divided by 2 epsilon naught m. I know the acceleration, I know the time, I know the displacement. So I think I'll have to use kinematic equation, which is S is ut plus half at square. If right side is positive, left side is negative, the displacement is negative 1 meter. Negative 1 meter, because it is clearly mentioned it is 1 meter away from it. It is 1 meter away from it. This was the initial, this was the final. That's why the displacement is negative 1. Initial velocity 1, time is 1 second, plus half into negative acceleration, because acceleration is towards the left side, following the sign convention. So sigma E divided by 2 epsilon naught m, and time, which is 1 square. So minus 1 and this one will become plus 1 plus 1, which is 2. It will become 1 plus 1, and this whole thing over here. So sigma E divided by 2 2s are 4 epsilon naught m. Solving this, you will get the value of sigma. Just check it out. If you get the value of probably whatever that alpha over there is nothing but 8. So you should get it as 8 epsilon m by E. So you will get it as 8. Yeah, makes sense. 4 into 2 is 8. Yes, 8 epsilon m divided by the electron charge. So that number which is missing is basically 8. Makes sense. Perfect. Matches. Okay. Brilliant question. Again, you had to visualize it. Once you visualize it, just have to apply the correct equations. Newton's laws was involved, kinematics was involved, electric charges concept, field concept, everything, sheet, field, everything, right? Beautiful question. We have two charges, 2 points in a field. Find the torque on the dipole. The torque on the dipole formula is dipole moment into the field. Field is already given. Dipole moment is not known, but dipole moment always goes from negative to the positive charge. So think about it. If I have a negative charge and if I have a positive charge, this is the direction in which the dipole moment will be. It will be the charge multiplied by the length vector. This is scalar multiple. How do I find that length vector? Oh, the coordinates are given. That's how I can find it out. So think about it. Length AB vector will be position of B minus position of A. Just like displacement is change in position, that straight line joining vector from A to B will be position of B minus position of A. So you just take these coordinates, which will be 2i minus j plus 5 minus A is I plus 4k. There is no j in that. So 2 minus 1 is 1, so I cap, minus j nothing. Okay, 5 minus 4 is just 1. So I cap minus j cap plus k cap is the length. So the dipole moment will be the charge. Take any one of the charges, which is 4 micro, multiplied by the length vector, which is I cap minus j cap plus k cap. Okay, perfect. So now let's find the torque. Torque is dipole moment cross the electric field. Dipole moment is given there. I just figured it out. 4 micro into I cap minus j cap, plus k cap. Cross it with the electric field, which is 0.2 I cap. Now remember, I cap into I cap is 0. I only goes with j and k. Do not forget that. So 0.2 into 4 is basically 0.8 micro. And I into I is 0 minus j into I. Well, think about it. That cyclic form I have given a small trick. You write ijk. If you go clockwise, it is positive, whereas if you go anti-clockwise, then it is negative. So using that logic, let's figure out what do we get over here. J cross I. J cross I. I'm going anti-clockwise, so it should be negative. But already there is minus sign over here, so it will become positive. So plus k cap over here. Here, k cross I. K cross I, I'm going in the clockwise direction. K cross I should get it as plus j. Okay, so I should get this as plus j cap. Okay, the magnitude of the torque is asked, right? And into 10 to the power minus 5. Okay, so if this is the torque, the magnitude of that torque will be 0.8 micro, and this will be 1 square plus 1 square, which is basically 2. So this will be 0.8 into 10 to the power minus 6 into root 2. So that is 8 into 10 to the power minus 5 root 2. So 8 into 10 to the power minus 5 root 2. So alpha is basically 2. Yes, it is the correct answer. Alpha is basically 2. The crux of the problem was this part where you have to find that displacement between point A and B, which will give you the length vector between points A and B. If you miss the sign, then also it will create an issue. Be careful about it. Always go from negative to positive while finding the dipole moment. Exactly. Okay, let's go to the next question on your screen. The electric potential at the surface of a nucleus of radius is how much? Surface of a nucleus. A nucleus has a charge of plus ZE. It's like a sphere, and that sphere obviously has some radius. Question is, what is the potential on that surface? Well, the potential on the surface is K, the total charge divided by the distance. K is 9 into 10 to the power 9. Radius, well, is the radius given? Yes. 9 into 10 to the power minus 13 becomes minus 15 in meters. What is ZE? That is the charge. So how much is that charge going to be? Think about it. Z is 50. Electron charge is 1.6 10 to the power minus 19. Excuse me. That's it. Solve this, you will get the answer. As you can see, you can use my trick of ignoring the decimals or the powers of 10 and zeros. 9 cancels, ignore the powers of 10. 16 and 5 are the pure numbers. 16 5s are 80, so 8 should be there in the answer. And the answer is 8 without even having to solve this. Okay, so the answer for this particular question will be 8 into 10 to the power 6 volts. That is the ignoring of powers of 10 and zeros and decimals. That is a trick where you can avoid the calculation. Okay, let's go to the next one. A thin metallic wire having cross section this much is used to make a ring of radius. Positive charge is distributed while the another positive charge is kept at the center. A tension in the ring is provided the ring does not get deformed. Neglect the influence of gravity. This reminds me of a famous problem which is also there in 𝑬𝒙𝒑𝒔 solved example in the chapter of circular motion, where there is a ring and it is rotated, and because of the centrifugal force it tries to expand and there is a tension in the ring. In fact, that was also a previous year question in IIT JEE Advanced long time back. So this question has been rephrased and asked over here. That's what I can visualize. So let's understand what exactly is happening. So let me show you. See guys, this is our ring and there is a charge present here. As mentioned, the ring has some charge which is distributed uniformly and another point charge is at the center. So what will happen? This point charge will create a repulsive force, at every point on that ring. This will be repelled here, 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 like this, like this, like this, like this. Now, because of this repulsive force, on the ring, what will happen? It tries, I am not saying it will, it tries to expand, but it can't. We have to neglect the deformation. Hence, it is under tension. It is under tension. Now, I can't draw the free body diagram of the entire ring because then the net force on it will be 0 and there is nothing great I can do about it. Rather, I will consider a small element of the ring. Consider a small element of that ring. Okay, so this is an element and we'll try to draw the free body diagram of that element, which is going to subtend a very small angle at the center. So let's think about it. Okay, so let's say this is our vertical line. This is that small element which we have considered. It has dq charge. Okay, and like said, the total element subtends an angle of d theta. So with the vertical or with the angle bisector, it will be d theta by 2, and this will be also d theta by 2. Our central charge is over here. Let's say I call it Q, or capital Q for that matter. For that wire, we have been given positive charges distributed uniformly. Okay, so no issues. Let's say lambda is given to us. Let's say lambda is given to us. Okay, for this wire. So this dq will be lambda into the length of that wire. So the length of the wire is the length of the arc. This particular part is the length of the arc. Arc length is radius into theta. So it is r into d theta. D theta is the total angle. Now, what are the kind of forces being experienced? Simply put, this Q will exert a repulsive force on this. That force will be dF. Okay, that force will be dF. And that dF will be given by, think of this element like a point charge. So point charge with the point charge will experience Coulomb force of repulsion or attraction given by K capital Q dq divided by the radius square, because that's the distance between this point and this point. It's an arc, but it's a small arc, so it looks like a point. So that's why I taken Coulomb's law. Apart from that, there will be tension here and there will be tension here. Remember, I told you the ring is under tension. Now, this tension will also have two components, one component here and the other component here, and one component here. Notice, if this is d theta by 2, even this angle will be d theta by 2. Same thing over here. So the vertical components balance df, the horizontal components cancel each other. So I can say in the y direction, the value of df is being balanced by two components vertical of the tension, which is t sine d theta by 2. Now, the interesting thing is sine of a small angle is the small angle itself. So I can just write it as d theta by 2. I need not put sine. 2 to cancel. So it will just become t d theta. Okay. What is df? We just figured it out over there. It was k q dq divided by r square. But dq was lambda r d theta. So dq was lambda capital R d theta, the whole thing divided by r square, and over here t d theta. Now you can obviously see d theta and d theta cancels, this r also cancels. So I'm just left with tension. So tension will be k q lambda divided by r. K is 9 into 10 to the power 9. Q is given. R is the radius. Lambda is also given because you know how much charge is distributed per unit length. That's it. Putting it, you will get the answer as 3 Newton. What a question, guys. So substitution was not the interesting part. The interesting part was taking an element, understanding why tension is there, and then drawing the free body diagram over here. If you are wondering how this d theta by 2 came, okay, let me also explain that part in detail on this particular part slide. So this is that arc, this is that vertical line, which was also the angle bisector, and the tension was over here. See, if this is d theta by 2, okay, if I draw another vertical line over here, these vertical lines are parallel. So if this is d theta by 2, alternate angles, guys, even this would be d theta by 2, correct? So this particular angle over here will be 90 minus d theta by 2. Naturally, if you go in the horizontal direction, this this angle will be 90 minus this angle, which is 90 minus d theta by 2. So 90 cancels, minus minus becomes plus, so it just becomes d theta by 2. That's why this angle also becomes d theta by 2, which is what I have taken over here. Okay, perfect. What a brilliant question, guys. Let's move on. Okay. Oh, we have come to the end of the class, and that were all the questions of JEE 2024 which we have solved right now in this particular session. But if you want 2022 and 2023, the link for the books is there in the description box with complete solutions. Not even a single question is missed. And see, what happens is, many times students think should we solve many books for JEE Mains. The answer is, there was a time where you had to find new questions, but now NTA is only giving you all the questions. So why do you want to look for anything else? So solving PYQs is a very good practice. Plus you are practicing same level, same pattern kind of questions. So you know what is important, which topics are given high weightage, which topics are not bothered by NTA. So you can start predicting the paper. So that is why I'm asking you to solve the previous year papers with full concentration, with full effort. Do not miss a single thing. The link is there for buying the previous year booklets, 2022 and 2023. Okay, all the questions, all the subjects will be couriered to you at your doorstep with the detailed solutions, and you will also see that every single question's solutions is elaborated in a proper way, and you can practice it with a proper book rather than using a PDF, because too much of screen time is again not good. So and place an order. The link is there in the description box below. Perfect. So with this session comes to an end, and I want everyone to comment below what should be the next topic. And also, if you watched it till the end, put up electrostatics PYQs done and dusted. Okay, electrostatics PYQs done and dusted in the comments after you have seen this. Okay, thank you so much, and do not forget to like, show your support for your Captain Shreyas and the VEDANTU JEE English. Bye bye, Captain Shreyas signing off. Hasta la vista.